Ladies and gentlemen, good afternoon. I'm professor in Haute École d'Ingénierie et d'Architecture in Fribourg, and every year we are organizing for the second year of bachelor a contest, well, several contests actually, because our mission is to learn students how to make engineering, to learn physics, and also to be able to create innovations, because it's the makers of tomorrow. And one of these contests is called the Hydro Contest. Hydro Contest is an international contest which has the purpose to find new ways to build ship in order to make them more efficient. Standard ship, for example, if you go to Mediterranean to go to an island, for example, it's ferry ships that use maybe between 7 and 11 tons of fuel per hour. So it's quite huge. So it's interesting to find ways to make them more efficient. So the contest is very simple. You receive one electric motor, one battery, and you need to build a ship and compete with other teams. And so that's what we did. And for example, in 2015, we made this ship. You can see that it flies over water, so it has wings which are underwater and goes over. This is a ship that we had last year, 2016, to carry 200 kilograms, and this is another ship lighter for 20 kilogram race. So the results that we obtained during 3 competitions in 2015, 2016, the race with 20 kilogram, the race with 200 kilogram, and the endurance race, 2 hours with the energy which is inside the battery. We were second, 8th and 1st in 2015, and 5th, 2nd and 1st for the 2016. So we are quite good in endurance. And of course, it gives a lot of joy to the students, because they were facing, for example, to the left, you have the École Polytechnique of Paris, and to the right, you have the people from Bretagne. So it's second year of bachelor from the Fribourg University. We never built ships before, and which are competing against university which are learning how to do state-of-the-art ships. And we cannot do it, but we try to do something. And so they are obliged to, our students it's necessary for them to find good tricks in order to make good place to this competition, which necessitates a lot of work and testing, of course. So the fundamental in this aspect is really the team, and the team, we can describe it in this type of contest as a social network of action. Action because they need to work, they need to think, so really they need to, it's very active. It's a network because they have links, they need to create links between them, and it's social because we're human and we need some social interactions in order to go further and to go beyond what every individual can do. The team values, there is a lot of values that needs to be put inside the team in order so that it works good. I will just give you the most important, according to our experience, is really the commitment to the goal. The goal needs to be defined. They need to define a strategy, what we will do this year to win the race. And everybody must agree to it, and they have to follow the same role, so same goal. Each member needs to take responsibility, and we always try to avoid people that are waiting for somebody to finish something or waiting for an order to make something. We really learn them to be responsible, to take responsibility in the project and to go forward. Very important is flat and agile organization. So we change the structure of organization. Of course, there is always a team manager, but according to the phase, we let the most talented people take the lead to operate efficiently one phase of the project. So we have something very agile. We fit the organization to the problem. So the organization can change from one problem to the other. And the other aspect is prototyping. It's second year of bachelor. They don't know the physics to make a ship. It's not possible to learn them properly this. So in 1 year, they need to understand what is a ship, how it works, and to make it better to win the competition. So they need to make prototyping, and they learn by doing it. Understanding and focusing, this is a really important aspect. It's winning, which means just finishing ahead. It's not to have the best ship. And that's very important. We never had the best ship, actually, but it was the one that finished the race and in proper conditions. And even one time we went full speed inside the, the pilot did not have a lot of experience with the new ship, and so he went at 25 kilometers per hour on the pontoon where the people were, and it makes a lot of noise. And since they didn't have all the knowledge to put just enough carbon fiber which is necessary, they put a lot more, so the ship did not sink. And so they were able to repair it, and 20 minutes later they were back into the competition, and they go forward. Another aspect is a mathematical theorem. The theorem of Bellman is a sum of optimized subsystems does not make an optimized system. So fortunately it works because we don't have the best motors, but we need to use this motor. And the team is part of the system, because it's something very important. A system is not only hardware, it's not only software, it's also people. And you need to integrate this into the whole. And one winner and many losers, of course. You have noticed that we are often second, and the second is the first of the losers. But all people can win knowledge and experience from the project, and also from observing what is important, what the other teams have done. Here you can see all the teams together, so you can see that they behave as gentlemen. And there is actually a very good exchange and very good atmosphere with all the other teams, and it's not a bad competition. It's really an open competition. And people are fair and are helping each other to make the best of each ideas, each ship that has been done. So sharing and laughing is also very important in such a contest. It's hard work, so if you don't have a good mood, it's difficult to go forward. And finally, what brings this competition to students? First is self-confidence. And that's really a very, very important topic, because when they have self-confidence, they can really try, and the more they try, the more they succeed. And so that's the very first goal that we have, is to bring self-confidence, so to bring them the tools and the methodologies to address problems in order to go forward. To restrain limits to imagination, and because if you don't know how to make a ship, then if you just do it, maybe you can find something interesting about it, and that's the way we go forward. It's also a teamwork experience, and that's one of the most important results of the contest. And it's also positive stress in a positive environment. We know that there will be only one winner, but we know also that the best we can do is to make the best out of the ship, out of the ideas that we had. So from the contest to efficient R&D, well, it should be about the same, because we need to innovate in a company. So we need to have this imagination, this teamwork, this trying to make the best out of what we can. So essentially, it's a good exercise to make R&D in the future for the students. And innovation is defined by Schumpeter as invention plus commerce. So essentially, they will need to work models with performance and cost. And actually, they already do it for the contest, because we don't have an unlimited budget to make it. We are not a Formula One racing team. So they need to make something cost efficient. In 2017, you can come and support us in September in the city of Saint-Tropez in France. It's in 65 days where the competition will be held. And take-home thinking, here you can see this is real reality. And now we are building, in the last 2 or 3 years, we start to build models, physical models, to help us in the process of first learning how it behaves and learning the physics behind. And so we go to virtual reality, but we know that this virtual reality is only one part of the problem, because you have all the second-order physics problems that you need to handle. And actually one force that we have now, since we asked them to experiment immediately with the ship of last year, they see all these second-order phenomena, so they feel it, they observe it. And so many of these real phenomena are difficult to model and to bring to virtualization. So we need to have this interaction from reality to virtualization and back to reality in order to make the process efficient. And if you don't like water, also in September this year, in Fribourg, we also host another competition, which is a gas balloon contest, and we also work in these topics. And since we are hosted by HE-ARC, we would like just to congratulate them, because they started with a fantastic victory in 2014 during the first year of the contest. And this year, actually, we failed early with our ships. Thank you very much for your attention.
Thank you very much. Very interesting. We have time for 2 questions, and the others, we will take them during the round table. So 1 or 2 questions? No question. It was very clear. Okay, I have a question. I will come back to your conclusion. This relationship between virtuality and reality. We know that simulation is always an approximation. It's not. It's not. But do you have some tools, or using I don't know, game or learning tools? Using virtual reality simulation, etc., to help these people in a short time to acquire a huge volume of knowledge in order to get this good ranking. So what is the magical formula you apply?
Well, essentially now we focused on team building and sharing experience from one team to the other. So it's and we start building the virtual reality tools in order to make simulations of the behavior, so that they can see how different design will behave on future. But now they really work on hardware first and get knowledge from observation. But we really see the advantages of this approach, not only for the teams, but also for all the students, because we see that somebody explained this, I think it was you, that the professor that comes and explains something and go away, it doesn't work that much anymore today, and we have good benefits if we can explain them. And so it's of course an investment in time, it's an investment in money and so on, but it's good to explain the fundamentals of physics in another way. And if we do it in our office during the weekend, it's not good, because we will achieve poor results. So we need really to invest more time in order to develop these tools, and also to be able to show different things to students, so that they can learn more efficiently. I've seen in the 1950s, a lot of professors used cinema methods, so films. They make films, educative films, and they were quite successful in it. And we are using now this. We are rediscovering this. These films, these movies about fluid dynamics. If you want to learn fluid dynamics with equations, forget it.
It means nothing.
Exactly. So we are rediscovering it, and we can push one step forward by making them in a virtual world with computer science and with specialists in designing games. Really, that would be fantastic.
Very nice. Thank you very much for sharing this experience with us. I'm glad to give you your certification.
Thank you very much.
Thank you. And now I invite. Yeah.